We all rely on, well, all sorts of invisible infrastructure every single day, don't we? For our comfort, our daily lives. Think about water to your tap, electricity for lights, and maybe most crucially, especially in the UK, the heating that keeps us warm. We often just take these vital systems for granted. But what if they aren't running as efficiently as they perhaps could be? What if that very infrastructure, the stuff designed to keep us comfortable, is quietly costing us a fortune? Or, undermining our bigger climate goals? Today, we're taking a deep dive into exactly that challenge. We're focusing on something called the Heat Network Efficiency Scheme, or HNES for short. This is a key UK government initiative and is specifically aimed at, well, supercharging the performance of existing large-scale heating systems across England and Wales.
That's right. And heat networks themselves, whether we're talking about those big district systems warming whole neighborhoods or communal setups just within a single block of flats, they hold immense potential. They can be really efficient, really cost-effective. But the reality, and this was highlighted back in a 2018 report from the Competition and Markets Authority and further work by DESNZ, the reality is that many of the existing networks in England and Wales are actually operating, well, pretty suboptimally. They're just not quite pulling their weight yet.
Right. And here's where it gets really interesting and directly impacts you, the listener. This inefficiency, it's not just some technical thing on a diagram, is it? It translates directly into higher prices, maybe poorer service for customers.
Yeah.
And in today's cost of living crisis, that hits home even harder in your wallet, in your comfort.
Absolutely. So in this deep dive, our mission really is to peel back those layers. We want to cover precisely how HNES steps in to tackle these specific issues. We'll look at who it helps, what specific improvements it actually funds, some might surprise you, and look at some fascinating real-world examples of its impact on the ground.
Okay, so to really understand HNES, we need to maybe peel back another layer first and get to grips with what these heat networks actually are. Beyond just pipes we don't see. So at its core, a heat network is just a system of pipes, right? Distributing liquid or gas, transferring thermal energy for heating, maybe cooling, hot water, to at least one building.
Exactly.
Now, within that broad definition, you mentioned two main types.
Yeah, broadly speaking, there's the district heat network. That's pretty much, as it sounds, it supplies heat to two or more separate buildings. Think of it like a centralized heating system for a whole area, potentially.
What?
Then you've got the communal heat network. Now, this serves only a single building, but crucially, that building is divided into separate premises. So a classic example is a large block of flats. Still centralized heating, but contained within that one structure.
Got it. So different scales, but similar principle.
And despite that potential efficiency in their design, many of these existing networks, well, they fall short. They lead to what we term suboptimal outcomes. And these aren't just minor issues. They show up in several ways that really hit the end user, the customer. For instance, you often see high heat losses across different parts of the network. That's just warmth literally vanishing into the ground or the air before it even gets to your radiator.
Just wasted energy.
Precisely.
Yeah.
Then there's often high pumping energy consumption. Lots of electricity wasted just pushing the heat around the system, sometimes inefficiently. And quite commonly, low heat generation efficiency. The central plant itself isn't creating heat as effectively as it should. All these technical problems can unfortunately lead to more frequent service outages or interruptions, and critically, a higher cost of delivered heat to the end customers. That directly inflates their tariffs, their bills.
So this really isn't just about abstract engineering problems with pipes and pumps, is it? For you, the listener, this boils down to the simple fundamental need for reliable heating when you need it. It's about having more stable, more predictable energy bills. And ultimately, it ties into the bigger picture, too, the wider energy landscape, pushing us towards solutions that are more sustainable and hopefully more affordable for everyone.
Absolutely. And HNES isn't operating in a vacuum here. It's actually a key component of the UK government's much broader heat network transformation program, the HNTP. That larger program, HNTP, is designed to really develop and grow the heat network market and, crucially, to decarbonize the UK's heat sector as a whole. It's a big ambition.
So HNES fits into that wider strategy.
Exactly. HNES itself has three core objectives. Think of them as strategic pillars guiding where the funding goes. First, and maybe the most obvious one, is to reduce carbon emissions simply by making these heat networks run more efficiently. Less waste, fewer emissions.
Makes sense.
Second, it aims to reduce customer detriment. That means tackling things like high bills and poor reliability, which in turn helps build overall consumer confidence in heat networks as a viable option.
Okay, that's crucial.
And third, it's designed to help prepare the heat network market for what's coming down the line, future sector regulation and technical standards. It's about getting the sector ready, setting a higher bar for performance across the board. The real genius of HNES, I think, and what makes it so impactful isn't just that it funds fixes. It's that it often forces this holistic health check on these often hidden systems. It recognizes that sometimes the biggest gains aren't in building entirely new stuff, but in meticulously fine-tuning what's already there, unlocking that immense, often overlooked potential for efficiency and cost savings.
That's a really powerful point about fine-tuning existing systems.
Yeah.
So let's talk about who can actually apply for this. Who are the organizations that HNES empowers to do this work?
Well, HNES funding is open to legal entities in England and Wales that currently operate or manage existing heat networks. And this covers quite a broad spectrum. You've got public sector organizations, think NHS trusts, universities,
Right.
then private sector organizations, provided they're registered companies, and also third sector organizations like registered charities or community investment companies.
Quite wide-ranging.
It is. The crucial thing to remember, though, is that individuals, just ordinary people, cannot apply directly. And while consultants can definitely help put an application together, they can't submit it on behalf of a client. The network operator or owner has to be the applicant.
Okay, that's clear.
Yeah.
You mentioned funding. What types of grants are actually available through HNES?
There are two main types. First, there are revenue grants for optimization studies. These are generally smaller amounts. They provide up to 100% of the eligible external costs. And typically they fall somewhere between, say, £15,000 and £24,000 per study, though you can ask for more or less if you justify it.
And their purpose?
Their purpose is to fund those external specialists, the experts, to come in and really dig deep, assess the network's current performance, pinpoint the exact causes of any inefficiency, and then recommend specific costed improvement measures. Think of it as funding the diagnosis phase.
Okay, the investigation. And the second type?
The second type is capital grants for implementation. Now, these are generally much larger sums. They provide part funding specifically up to, but importantly not including, 50% of the eligible project costs. So it's a contribution, not the full amount.
Right, match funding effectively.
Something like that, yeah. Applications for these can vary hugely in size. There's no lower limit, technically, but they can go right up to £10 million, although grants over £1 million trigger some extra checks. And the aim of these capital grants is pretty straightforward: to part fund the actual installation and delivery of those efficiency improvements that were identified, perhaps in an optimization study. So these are the funds to actually do the repair and upgrade work.
Gotcha. So it's not just a case of filling in a form, though.
Yeah.
You said earlier it's competitive. It sounds like they're really looking for projects that, well, maximize the benefits, with a keen eye on helping customers and delivering those solid efficiency and carbon savings.
Exactly. It's a competitive process, and funding is prioritized based on demonstrating strong outcomes in those areas: customer benefit, carbon reduction, efficiency gains, and overall value for money.
Okay, so let's drill down a bit. What exactly gets funded? When HNES steps in with those capital grants, what sort of improvements are we actually talking about?
They really look at the whole system, the entire sort of nervous system of the heat network. So improvements could be at the very start in the energy center or plant room. Things like reconfiguring pipework for better flow, putting in new smart controls for the heat generation plants, maybe replacing or even removing inefficient pumps, insulating pipework in the plant room itself.
Right, at the source.
Then they look at the distribution network. Those are the actual pipes snaking through the community or building. This could involve replacing sections of pipe, reconfiguring them, definitely adding insulation to distribution pipework, including the laterals and risers going up buildings. It can also cover upgrading the heat interface units, the HIUs within buildings, or maybe just replacing faulty parts in them.
Okay, the bits connecting to the building.
Yes. And then they focus on the tertiary network, which is the system within the final building closest to the customer. This could support measures like system balancing or flushing to improve flow, or installing tertiary system controls like smart thermostatic radiator valves, TRVs on radiators.
So right down to the radiator level, potentially.
Well, the controls on the radiator, yes. Not the radiator itself, usually. And finally, there's metering. HNES can fund the installation of submetering or even new customer-level meters, but only if a specific cost-effectiveness assessment for the heat network metering and billing regulations, the HNMBR, comes back negative. They can also fund smart solutions that integrate both controls and metering, which is quite forward-thinking.
That gives a great picture of what is covered.
Yeah.
But it's just as important, I think, for clarity and maybe for those aha moments for listeners to understand what HNES doesn't fund.
Absolutely crucial.
So, for instance, it won't cover costs you've already incurred before you get a grant award. That's pretty standard. It also steers clear of general improvement to the building fabric itself, like putting in new windows or insulating walls, unless it's directly related to insulating the heat network pipes passing through.
Correct.
And critically, you mentioned this implicitly, but HNES does not fund the replacement of the primary heat generation source. So if you've got an old gas boiler running the network, HNES won't pay to replace it with a shiny new gas boiler or even a heat pump.
That's exactly right. And this points to that broader UK strategy we touched on.
Yeah.
While other government schemes like the Green Heat Network Fund, GHNF, are specifically focused on those big decarbonization projects like replacing fossil fuel boilers with heat pumps or waste heat recovery.
Yeah.
HNES is very strategically targeted at tackling the existing network inefficiencies. It's the sort of quiet, foundational work that ensures those bigger, greener investments in new heat sources actually deliver efficiently down the line to the end customer.
That's a really key distinction. It makes sense. It's about making the delivery system efficient before or alongside changing the source.
Precisely. And just to circle back quickly to those revenue grants, the optimization studies they fund, the scope is quite comprehensive. They involve properly baselining the network's current performance, getting the hard data, then thoroughly investigating any operational issues, often using quite advanced diagnostic tools and modeling, and finally, developing those detailed, costed recommendations. And importantly, those recommendations cover both the technical fixes and potential enhancements to the customer experience. So it's a truly holistic approach to improving the network's efficiency and service.
Okay, it's one thing to talk about policy and funding streams on paper, but where the rubber truly meets the road, as they say, is in the real world. Let's maybe explore how HNES is making a tangible difference with a couple of compelling case studies.
Yeah, definitely. One really excellent example is Coventry City Council's One Friargate building. The problem they were facing was pretty significant energy waste. It showed up as high return temperatures coming back from the building to the network and low temperature differences across their system. Those are classic signs of inefficiency in heat networks.
Okay, so energy just cycling around wastefully.
Pretty much. The solution came through an HNES-funded optimization study. This was conducted by a specialist company, Hydronic System Optimization Ltd. HYSOPT, and they used their hydraulic digital twin model, so a sophisticated computer simulation of the system.
Wow, okay, high tech.
Yeah. And the key recommendations that came out of this digital analysis were quite insightful. They recommended replacing older, less efficient three-way valves with modern two-way valves. This helps convert the system to a variable flow system, which is generally much more efficient. And alongside that, implementing new controls within the Building Energy Management System, the BEMS.
And the results.
The benefits were pretty profound, actually. They saw a significant reduction in the energy used by the pumps. They achieved a lower return temperature back to the main district heating network, which is really key for the efficiency of the whole wider network, not just their building. Reduced carbon emissions, obviously. More cost-effective heat for the people actually using the building. And interestingly, it even created some spare capacity on their connection, potentially allowing for future network connections nearby, a fantastic bonus for urban development planning.
That's impressive. It sounds like a win-win-win.
It really was. And, Councillor Jim O'Boyle from the council summed it up well. He said, "This study was vital for us to review our heating systems, improve their efficiency, and ultimately cut down on heating costs." Shows the real value they saw in it.
And it's not just commercial or, standard residential buildings that are benefiting from this, is it? We should think about places where consistent, reliable heat is, well, quite literally a matter of life and death.
That's a very important point. And it brings us neatly to the Hull University Teaching Hospitals NHS Trust. Their two main hospital sites, Hull Royal Infirmary and Castle Hill Hospital, they collectively house around 1,300 beds. They rely absolutely on efficient, uninterrupted heating for patient care, operating theaters, everything.
Absolutely critical infrastructure.
Totally. But their existing heat networks were, frankly, degrading. They were inefficient and they suffered from poor metering, so they didn't really know where the heat was going, and aging, failing insulation on the pipework. The HNES intervention here was crucial. The scheme provided over £250,000 in capital grants spread across 2 separate applications.
Okay, and what did that funding achieve?
With that funding, they managed to install an impressive 1,880 meters. That's nearly 2 kilometers of new high-spec pipework insulation. And they also installed 22 new accurate heat meters at key points in the network.
So plugging the leaks and getting better data.
Exactly. The actual energy savings from these vital improvements are still being calculated. They expect figures by the end of 2025. But the impact on the system's reliability and its baseline efficiency is already palpable for the trust. It's a huge step forward for them.
That's fantastic to hear, especially in a hospital setting. Okay, looking ahead then, for organizations out there listening, perhaps operating a heat network, who might be considering applying, let's talk a bit about the application process itself. We mentioned it's competitive, and you said priority is given to projects that tackle customer detriment, especially helping those most in need, and also delivering big efficiency gains and carbon savings.
That's right. The assessment process really hones in on those aspects. They want to see a clear plan for addressing customer detriment. And they specifically look for projects supporting what they define as customers in need.
Okay, could you define customers in need in this context?
Sure. It refers to dwellings where the residents are considered financially vulnerable and where they'll significantly benefit from reduced heating costs or maybe service improvements funded by HNES. So this includes categories like social housing, other low-income housing, customers identified as being in fuel poverty, extra care housing facilities, low-income care homes, and supported housing schemes.
Right, so there's a strong social impact focus woven right into the scheme's priorities.
Absolutely. It's a key part of the assessment criteria.
And for those interested in practicalities of applying, how does the timing work? Are there specific deadlines?
Yes, HNES operates on a system of funding rounds, providing regular opportunities throughout the year. It's not just open all the time. So, for example, as of today, August 6th, 2025, Round 10 is currently open for applications, and it closes on September 19th, 2025.
Oh.
Looking ahead, Round 11 is expected to open around December 1st, 2025, and then close on February 6th, 2026. And beyond that, further rounds are anticipated Round 12, likely opening March 2026 and closing May 2026, and Round 13 opening around August 2026 and closing October 2026. So, regular chances to apply.
Good to know there's a predictable rhythm to it.
And it's worth mentioning, too, how this scheme fits into the broader picture of regulation, which is really evolving quite rapidly for heat networks now. It's becoming a much more formalized sector.
Ah, yes, you mentioned preparing the market for regulation as an objective.
Exactly. For instance, the Heat Networks Market Framework Regulations 2025 actually just came into effect on April 1st, 2025. This is really significant because it means the Energy Ombudsman now accepts disputes from all heat network customers, regardless of their supplier. That's a huge step up in consumer protection, and suppliers have to get registered under this framework by January 2026.
Okay, big changes there.
Yeah. And furthermore, the Energy Act 2023, that provides the government with powers to actually mandate technical standards across the sector in the future. And looking just a bit further ahead, the Heat Network Technical Assurance Scheme, known as HNTAS, is due to launch in 2026. This will likely require heat networks to pass regular assessments to prove they meet minimum performance and reliability levels.
So HNES is kind of helping networks get ready for that future scrutiny.
In many ways, yes. By funding efficiency improvements now, it's helping networks get their house in order, ready to meet those upcoming standards and regulations. It's all moving towards creating a more robust, accountable, and high-performing heat network sector overall.
That makes a lot of sense. So if an organization is listening now, maybe an NHS trust, a university, a housing association, and they think, this sounds like it could apply to us, what should they do next? How do they find out more or start the process?
The best starting point is usually to get in touch with the scheme administrators. You can email them at HUSNE@gemserve.com. Through that email, you can submit an expression of interest, you can request access to their online application portal, or you can just ask to be added to their mailing list to receive updates on funding rounds and guidance.
Okay, HETSH@gemserve.com. Simple enough.
And they also offer something quite valuable, a dedicated relationship manager service. This provides bespoke guidance tailored to your specific situation, which can be incredibly helpful for navigating what can feel like quite a complex application process, especially for the larger capital grants.
That sounds like a really useful support mechanism.
It is. And just to give listeners a sense of the expertise involved in actually running the scheme, it's delivered by a consortium of specialist partners. GemServe, who you email, handles the overall delivery and management. Ramboll, an engineering consultancy, takes care of the technical application assessment. Gleeds provides independent cost consultancy, making sure the figures stack up. And LuxNova Partners offers legal advice related to the grant agreements.
So a solid team behind it.
A very solid, experienced team, yes.
Yeah.
Ensuring expertise across every stage, from application to delivery.
Okay. So we've journeyed quite a way today. We started by peering into the, well, often hidden world of heat networks, understanding what they are and the sometimes overlooked challenges they face with inefficiency. Then we saw how a targeted strategic government scheme like HNES is stepping in, providing funding not just for quick fixes, but for deep analysis and substantial upgrades. It's making a tangible difference, not just in improving technical efficiency and reducing carbon emissions, but crucially, making a very real positive impact on people's lives through potentially lower bills and more reliable heating, and focusing on those most in need.
Absolutely. And if we just connect this back to that bigger picture one last time, HNES isn't just about fixing today's problems with pipes and pumps. It's really laying crucial groundwork. It's helping build a more efficient, a more equitable, and ultimately a decarbonized heat sector for the UK. It's actively helping to shape our energy future, one optimized network at a time.
A really important piece of the puzzle. So maybe a final thought for you, our listeners, to take away. Next time you feel that warmth radiating in your home or your office, or perhaps even a hospital, take a second to consider the intricate, often completely invisible networks that deliver it. And maybe ask yourself, what other hidden systems around us, systems we rely on every day, might be right for their own efficiency deep dive? And what surprising benefits could that unlock for all of us?